Hey everybody, my name is Svet Ganov. I'm the tech lead for the Android runtime permission model. I'm the TL for Android printing, accessibility. I worked on various other things. And
my name is Jeff Sharkey. I'm a software engineer on the Android framework team, and I've worked on things like SD cards, package management, and parts of the networking stack. Today, Svet's going to dig into permissions and how they've evolved in Marshmallow, and then I'll be back up to talk about best practices. Svet?
Thank you, Jeff. Before I begin my talk, you're probably wondering, what are these permissions? What is this guy going to be talking about? So before I get into the nuts and bolts of permissions, how the new runtime permission model works, I want to cover the very basics and what is a permission. So a permission is it controls access to sensitive data. For example, my contacts, my SMS, and critical resources. So critical resources are, for example, the camera, the GPS. So permissions are granted to applications by the user. And there are three different protection levels of permissions. One of them is normal, dangerous, and signature. Normal permissions are considered not that harmful to the user, and applications usually get them immediately as soon as they're installed. They don't need user approval. Dangerous permissions, they are more critical to the user, and these are things like your contacts, your camera, location, which require the user to opt in and allow the application to use the permission. There is a third type of permission, which is called signature permissions. Signature permissions are defined by an application or the platform, and in order for another application to get this permission, it has to be signed with the same certificate. This pretty much means that it should be developed by the same developer. I'm going to do a very quick dive on how permissions used to work before on L and pre-M devices in general before I dive into the new permission model. So what you probably most of you know on L devices, you just go to the Play Store, you find an application you want to install, you see the familiar install button, you click the install button, you see this nice list of all the permissions that the application is using, and you have basically two options at this point. Accept all permissions or go away, go back. And even if you don't like one of those permissions, and if you have some doubts, you basically have still these two options, like opt-in or completely don't install the application at all. Assume that I approve all permissions, the application gets downloaded, I open the app, and the application can be used all the time. So the old permission model had several limitations. So for one, the user had no control. So basically, you have the big hammer. You either hit the nail or you don't. It's basically you either accept all permissions and install the app or you don't. There is no context for the user why this application needs this permission. So you're probably asking, why is a flashlight app asking for some permission? And there's probably a good reason for that, but the thing is, it's not obvious every time why the application is a certain permission. Another problem we had was we had too many permissions, and it was really hard to make an informed choice when you have 30 options and you need to understand 30 different concepts to decide what to do. Another problem is the technical jargon that was used by the explanation for certain permissions, mainly because it's been evolving over time, and we've been adding more and more concepts. And to be honest, I'm an engineer working on this, and still it was kind of hard to understand all the permissions at some point. I just need to look it up and, what was it? And the other is, which is really important for you guys, app developers, is there was friction on upgrade. Because if you get an update for your application and you require new permission, the user has to explicitly approve it before the upgrade occurs. And this is problematic because many times developers are afraid to add new features because they may require new permission. Since this can limit the adoption of their application, and they're really trying to, or this could lead to the other pathological case where you request all permissions up front, just in case, you never know. So in order to solve all these problems, I'm presenting how permissions work on M, or Marshmallow. So what we did is we realized that we have too many permissions. And we decided to group the permissions into 9 permission groups which are oriented by topic, and this is what we present to the user when they manage the permission. So the user can, if the user grants you the contacts permission, they under the hood grant you all the permissions in the contacts group. So all the permissions are runtime. So there is no permission UI when you install the app. So if you go to the Play Store, you find your application, you see the install button, then you click install. And the installation starts right away. You don't see any UI, any dialogues for permissions, and you can open the app. So what the app does is when the application needs permissions, it does request them at runtime. And this is one example of how the calendar app is asking for your contacts. So the idea behind this permission model is that the user has more context why the permission is needed for, because you're trying to use a feature. You're trying to take to use the camera, and when you try to use the feature, it's asking for the camera permission. It's pretty obvious why the permission is needed, and you have more context and more informed choices. The other benefit of the new permission model is that you can always change your mind. You can say, hey, I granted this app this permission, but I don't feel comfortable for the app to use this permission. You can always go to settings and change that. Or so you have access to permissions by application. So now you can see all the permissions that the Hangouts app is using. You can also see the permissions. So which apps are using this permission? So for example, which apps are using the camera permission on my device? And you can control that. So this is how modern applications work. So your application has to be explicitly written to use the new runtime permission model, which is probably 0.1% of the applications on the Play Store. And you're probably asking yourself, what do I do for all these 99.9% of the applications? How do they work? Because the way they're written, they don't expect permissions to be revoked on them. So if you revoke the permission on an app, it will just blindly call the API, and it will just crash. So the way permissions work for legacy apps is you go to the Play Store, again, you find the application, you click the install button, you see the familiar permissions dialog, and again, you have two options. You either accept all permissions, or you go back. The difference, though, is when you install the application and accept all permissions, now you can go to settings and you can manage permissions for those applications, even though they don't support the new runtime permission model. And then the question is, again, you have the 9 permission groups. So from this point on, for you, the application is controlling permissions for legacy and non-legacy apps is absolutely the same. There is no difference. And then the question is, how did you guys do this? The way we do it is, instead of revoking permissions for legacy applications, we're just disabling the API. We're using a feature called AppOps. Probably some of you are familiar with it. And what we do is literally, for example, you revoke the contacts permission. So the application really has contacts permission. We don't revoke the permission, but what we do is, when the application is asking for contacts, we say, sorry, no contacts on the device. So we're basically making the APIs do nothing or return default errors or empty data sets. It's case dependent. So we basically had to visit all the APIs and just make them work appropriately. So how do you ask for permission? And before I go into the nuts and bolts of how to do it in code, I really want to cover the UX, because it's really, really important to have consistent permission experience for all applications. It's good for the user, it's good for you, it's good for the ecosystem, it's good for everyone. So you can imagine a 2-dimensional matrix. So in one dimension, you have how important is this permission for my application? Is it critical, or is it an optional feature? So for example, if I have a camera app, the camera permission is critical for my app. I mean, it will not work if I don't have the camera permission. However, location is a different story. Maybe I have a geotagging feature, but most users probably don't understand how location is related to photos. And in this case, probably I don't need this permission right away. It's not critical for my application to work. Also, it's about context. The other dimension of this matrix is the context. So is it clear to the user what you need the permission for? Or it's not clear. And based on that, I'll cover all the cases and what is the UX recommendation in each of these cases. So case 1. Assume that it's a critical permission that your application needs, but it's not clear to the user, why do you need this permission? So now that's a great opportunity for you to have a warm welcome screen where you present the core features of your application and how to use the application, and you educate the user. And in this context, it will be clear to the user why this permission is needed. And at the end of this flow, you can just literally request a permission, and the user will not be wondering, why do you need this permission at all? So the second pattern, asking upfront. So if you have an application that really needs this permission and it's very obvious, so the camera app is a perfect example. You have a camera app, you need the camera permission. Without the camera permission, the application cannot work. So for the user, it's not surprised if you ask for the camera permission. They just downloaded the camera app. So the third case is for secondary features where it's obvious why you need this permission. For example, let's pick the geotagging example that I gave you a minute earlier. So if I have a photo and I select to geotag the photo and I'm asked for location permission, I wouldn't be surprised. It's obvious to me. I can see in the context that, oh yeah, I know why this permission is needed. So the fourth context, the fourth pattern, excuse me, is educating context. So this is for cases where it's a secondary feature for your application and it's unclear to the user. So you really shouldn't have features that fall into this bucket, but in case you do, you should educate. You can explain before you request the permission. You can educate the user why you need this permission before you ask the permission. We have even a dedicated API which has this long name, should show request permission rationale, that you can use as a hint whether to show a permission rationale. I'll cover this in detail a bit later, but what I forgot to mention is really important is that when you ask for permission, the very first time, the user has two options: accept the permission or deny the permission. They do not have the option to say, don't ask me again. So the very first time, it's safe to ask. The second time, if the user says no, but the application keeps asking for the same permission, now the user has the option to say, nah, don't ask me again. So the very first time it's safe. That's a very important message. Just ask for the permission upfront. So there is a fifth pattern, which I would say it's more like anti-pattern. I've been asked this question many times, so this is why I decided to bring it up to your attention. But to be honest, from all the Google apps that were seeing this as a problem, nobody actually had to implement this pattern, and there was another way around that. So that's the case where you have a service, it runs in the background, and you don't have UI, the user is not using the UI of your application, and now you need a permission. So what do? We don't have APIs to request permissions from services, and that's on purpose because we don't want to interrupt the user. So definitely, when the user is using another app, you shouldn't throw an activity in front of them asking for the permission because this is disrupting the user flow. What you should do is, first, avoid this if possible. And the other is just post a notification and say, hey, this feature won't work. And when the user has time, they can open a notification, when they click on the notification, you should bring a full screen UI where you can explain what feature needs this permission, why is this permission used for, and let the user choose whether they want to opt in, at which point you can request permission, or opt out. So here are the permissions APIs. There are just a few APIs you need to learn. They're very, very simple. I really want to have this message that it's very, very, very simple to use permissions. So the first permission is the first API is very simple. Do I have this permission? Which means, does my app have the permission, not somebody who's calling for a remote process. The second API is to request the permission. As you can see, we have these APIs on activities and on fragments. Once you request a permission, you need an API because permission request is asynchronous. This brings a UI. The user has to decide what to do. So this is why you have this callback on permission result request, on a request permissions result, where you need to handle the result of what the user decided to do. The last two APIs are a little non-obvious what they do. The should show permission rationale. So this API it has very targeted use, and it's intended for. So this returns true if and only if the user already declined the permission once. So you requested a permission, the user saw the UI, and said no. And now you can use this API that as a hint whether maybe the user didn't have enough context when they requested the permission the previous time, when you requested the permission the previous time. So you can help the user and show this additional educations, additional screen to explain why you need the permission. But again, this is very optional, and this is only if you feel that the user doesn't have enough context. We really think that most of the time this shouldn't be needed, but in case you do, it's there. There is another case where you can have device policy that says, no, this application does not have this permission and it cannot get it. So the way to read this API, is permission revoked by policy, is does the user have the power to give me the permission? So if the user doesn't have the power to give you the permission, you may not even expose the feature because, or you can explain to the user that the feature is not available because the policy doesn't allow this permission. Now that we have all the building blocks, here is how we put them together. It's really important. The very first thing you need to do when you call a permission-protected API, always first check whether you have the permission. So if you have the permission, just go ahead and do the work. If you don't have the permission, now you can optionally check, should I show rationale? So should I help the user better understand why I need this permission? Because if the user already declined the permission, and otherwise, you just go ahead and request the permission. Once you request the permission, you need to handle the result based on what the user decided. So this is how permission result handling looks like. So the first thing you need to check is this the request I made? Like, is this the answer I'm waiting for? If that's the case, the next check is there information in the answer? So are these arrays with permissions and results empty? So if they're usually empty if there is a cancellation. The next thing you check is, did I get the permission? If you get the permission, go do the work. So it's all great. How do you get on the boat? Like, how do you get on the train? How do you opt into the new permission model? It's based on the target SDK. So what you need to do is change your target SDK to 23 and magically use the new API, and you're in the new permission model. It's important to note that there is no way out. Once you get in, there is no, you cannot go back to target SDK, say 22. And this is the main reason for that is we want to, we really believe that runtime permissions are really good for the user. They're really good for developers. They're good for the ecosystem. And we really want to incentivize everybody to use this new permission model. We have these very special cases which I want to point out, very, very useful API. One of them is, say you have a new feature that you want to use. So you want to add camera feature only for M devices and up. You don't want to request the camera permission because this can affect your adoption on older platforms. So what you can do is, hey, I want to use this permission, but only on platforms that support runtime permissions. So users permission SDK 23 is your friend. We have another way of requesting permission up to given SDK. So you say, hey, I want this permission up to L. So the way you do it, and you specify max SDK version in the users permission API in your manifest. So upgrades. What's the upgrading story? Permissions are grandfathered. So if you have an L app on L device, you have all the permissions. If the device gets updated to M, your application still has all the permissions. With a caveat, the user can go ahead and revoke the permissions. If you upgrade your application from target SDK 22 to 23 to opt into the new permission model, you still keep your permissions. Also revoke permissions if I install a legacy app targeting L SDK, and if I revoke some permissions as a user, when I get the update, the same permissions are still revoked until I go ahead and grant them explicitly. So we have support library API. I will not go into details, but the message here is for all the APIs that you saw in the SDK, there is corresponding APIs in the support v4 library, so you can use permissions from the support library. We also have APIs in the support library v13 if you don't want to go back to v4. And this is kind of an edge case which I really wanted to point out for proxy in permissions. This is, again, very edge case. Usually this happens when, say I have an app that has access to contacts. And I decorate contacts. So for every contact, I'm adding a smiley face, for example. And so when an app is asking me, so I have the contacts permission, I have access to all the contacts, but if an app is asking me, hey, give me the smiley face contact, I need to verify whether this application has the contacts permission in the first place, because I don't want to be leaking the contacts permission without user approval. It's really important to use the permission checker from the vFort support library to do this, because it checks not only the permission, but it also checks whether the APIs are enabled. You guys, if you remember, for legacy applications, we don't revoke permissions, we disable the APIs. So the permission checker knows how to check the permission and whether the API is disabled by checking the corresponding app ops. There are some command line tools that are very useful. Some of them is ADB shell PM grant revoke. You can use this to grant revoke permissions to your app. Like during development, is very useful. Instead of having to manually approve the permission every time, you can literally grant and revoke permissions from the command line. Another thing that's very useful for developers is if you want to install the application with all permissions granted, you use the familiar ADB install with the -G, which means grant all permissions, specify the package, the APK, and all permissions are granted. Sometimes it's useful to dump the state of permission state for your application. ADB shell dumps this package and then a package name, dumps the state of your package in the package manager, and it also lists all the permissions. We also have some device policy APIs. This is very for people who write device policy, which is fairly rare, but there is a way for you to specify, hey, this permission for this app is always granted or it's always denied. Or you can say, hey, for every subsequent request, I want permissions to be automatically denied or automatically approved. So some do's and don'ts. Please never don't code around permission groups. No, don't assume that if you have one permission in one group, you have the other permissions in the same group. We reserve the right, because at the application level, you're operating at the raw individual permission level, and the user controls the permissions at the group level. So it's a simplification for the user, but please don't assume any grouping behavior. We want to reserve the right to add new permission groups, move permissions between groups. I'm not saying we will do it, but it's just for the flexibility of the platform. Also avoid screening questions. Hey, if I ask you this permission, are you going to give me this permission? We want you to ask upfront, because the first time there is no penalty. There is no don't ask again option for the user if you ask for the very first time. Also, follow the UX patterns. It's really important that all the applications are consistent. It's good for users. It's good for you. It's good for everybody. I want to stress again, check before you call an API that is protected by a permission. Don't assume that you have the permission, or don't rely on some previous checks. And this applies to any API. It's not only for permissions, but don't infer undocumented behavior. Don't rely on undocumented behavior, because we may accidentally change that, and we may accidentally break your applications. We are trying really hard to be backwards compatible, but sometimes it's hard. And probably you have the question, hey, how do I know which APIs are protected by permissions? Which is an interesting question. It was never documented. So you can use Android Studio, actually. Android Studio is flagging if you call an API without checking for permission. With this asterisk that not all APIs are probably annotated, we have this special annotation on the API which permissions are guarding it. So in some cases, you may have it may have some misses, but we're trying to get it better and better. So with that, I'm tossing over to Jeff to talk about how not to use permissions.
Thanks, Svet. So yeah, thanks. Svet just explained to us the new runtime permissions model in M, how things changed and evolved there, and these powerful new permission groups that we have that you can request from users. But I'm going to shift gears and talk about how you as an app developer can actually ask the user for fewer permissions over time. So as an example, again, we have these permission categories. They're nice and shiny, but some of them can be pretty broad and scary. you as a developer, you're asking the user to give you access to all of their contacts, to all of the files that they have on their SD card, including all the photos that they've taken in the past. And so some of these permissions, they may make sense for your app. Again, if you're building like that camera app, you need access to the camera permission to make that happen. But other times, you may be asking for more than you need. So that's what we're going to do. We're going to go through a couple of these common categories. We're going to look at use cases, common use cases that you as an app developer may have. And we're going to look at ways to still build those parts of your application without requesting the big, broad, scary permissions. So the first one we'll dig into is storage. You probably recognize this as read or write external storage if you've added these permissions to your manifest. And when you ask for the user for this permission and they grant it, the user is giving you access to all of the files on their card. Even if you as an app developer, you're not interested, you're still requesting and getting access to all of that. Some common use cases as a developer is you might just be looking for a place to store additional data. You're trying to be helpful. You don't want to take up the user's valuable internal storage space. You want to put that content out on an SD card, maybe a 32 or 64 gig card that the user's inserted. A second use case is maybe you want the user to pick individual files to work with. If you're a photo editor app, maybe you just want to open the one or two files that you want the user to work with, and you're not interested in all those other details. So let's dig into the details. For that first example, there's a handful of APIs that were introduced in KitKat on context called get external file dirs, cache dirs, and media dirs. And when you call these, the paths that are returned, they exist on the SD card, but they have your package name burned into them. So if you look at the bottom, you can see the example of what those returned paths look like. So notice it would be under the SD card /Android/data /your package name. And there's a couple reasons for that. First of all, that's how the system recognizes who that data belongs to, so that it can give you access to that data. So the paths that are returned from these APIs, your application always has read and write access to any contents under those directories. You're free to create new directories, new files at any time, and there are no permissions required to do that. You don't need to request those read or write permissions. They still will work even if you have those permissions, but you don't need to request them. The other benefit here is that there's better accountability. The user, if they go to uninstall your application, the system will automatically clean up any files that you've chosen to store in those locations. In addition, if the user goes into settings to see where their disk space is being used, it'll be accounted against your application correctly. So it's better for a lot of different reasons. The next example that we talked about was just looking to pick an individual file or work with a handful of files. And this is where I'd like to take a second to talk about the storage access framework. This is something that we built in KitKat, and it's really an abstraction layer between apps that offer to store files or data, say like an SD card or Google Drive in the cloud, and apps that offer to work with content or files, say like a document editor or a photo editor. So in this case, instead of asking the user for those broad permissions, asking for all of the files on their SD card or all of the contents of their Google Drive, you as an app developer, you're able to launch a handful of common intents that go into the storage access framework and ask the data what files would the user like to work with. And they're given that freedom to choose which things they want to return access to your app. The handful of intents that are interesting here are open document, create document, and get content. You can think of those essentially like an open file dialog box, save file, and more of like an attach file if you're building like an email application. And we'll dig into it in a moment and a little bit about how that works under the hood. Another thing to mention is in Marshmallow, we added access to USB OTG or on-the-go devices. So if you have a USB flash drive that you've plugged into your device, those are now available through the storage access framework. And so you as an app developer, if you were using these intents, you didn't have to add any additional code to start working with those devices. They automatically appeared. And that's true of any other, either a cloud storage provider or any other storage medium. If they participate in storage access framework, there's no additional work that you need to do as an app developer. And it gives users more freedom and flexibility. So then you might ask the question, how does this, here's an example actually. We'll take a look at just some of that UI around that experience. So these are those three intents: open document, create document, and get content. And it's one thing to point out here is that we're giving users a consistent experience when they go to pick these files. You could build your own UI for navigating the contents of the SD card, but as the user comes into your app, they're going to have to understand how you've chosen to represent some of those concepts. And it'll be slightly different than every other time they've encountered that before. But by using these common intents, we're giving UI that the user has probably seen a couple other times on the platform. They're already familiar with how to navigate and use, to navigate and pick the files that they're interested in. And this is beneficial for the user because they can get the task that they want to do. They can get that done faster. They understand how to interact with this framework. So now let's dig a little bit deeper under the hood. How does Storage Access Framework actually work? And I'll talk a little bit about URI permission grants. So all of the stuff we've talked about earlier today are focusing on traditional Android permissions, which are a string, like android.permission.readExternalStorage. And that's something that your app requests in your manifest. And when the user grants that access, you're granted that for the rest of the lifetime of your app, either until the user uninstalls you or until the user goes into settings and revokes that permission. URI permission grants are slightly different in the fact they're centered around content providers. So a content provider, it surfaces its content on the system through a URI, a content : // an authority, and then a path name. And the power here with URI permissions is that we can grant access to a very specific path inside of a content provider for a limited amount of time. So for example, if I just took a photo in my app and I want to share it with someone else, I can extend access to just that photo that I just took to the receiving app at the other end temporarily. And the lifetime of that permission is until that activity stack finishes. So I extend them access. Maybe I'm sharing it as part of a social network. They get access. They can see the data that they need to get their job done. And as soon as the user leaves that activity stack, the permission is revoked. So they only had access to the data that they needed and for a very limited time. So you might be asking the question, how do I wire this up inside of my app? And one of the easiest ways to do that is using a class called file provider in the support library. It allows you as a developer to easily convert. If you have a file on disk, you can convert it into one of these content URIs that then you can stick into just a traditional intent that you might already be using today. So in this case, there's an intent.actionSend. And instead of using a file URI, we're sending a content URI to the other side. And that's what allows us to use that additional flag there, intent.flag grant read URI permission. And this is you as an app developer communicating to the system that you want to extend temporary access to that URI to whoever receives it at the other end. And one of the reasons this is becoming more important in Marshmallow is that you may not know, whoever's at the receiving end, they may not have that storage permission, or they may not have the permissions to access that content outright. So this is your way of making sure that whoever's at the receiving end, they have the permissions that they need to access the content under the hood. So in summary, even if you're using file URIs, you'll want to look at transitioning them, even in M, more towards using these content URIs because of the power that comes from them. And there's a strict mode API that you can use to help track down in your application. If there's places that you might still be using file URIs, you can turn on that strict mode, and it'll log it, and you can quickly figure out if there's any places that are still lingering around. All right, so we've talked about storage. Let's go into another category. Let's talk about phone. A couple permissions that fall under that category, read phone state and call phone. And these are pretty powerful too. When you think about it, they give you access to see the user's phone number, to see their IMEI, to read the current state of the phone. Are they in a phone call or not? In reality, you may have a couple common use cases like for example, you're just interested in using the IMEI as a unique identifier to be able to figure out which device is this. Or you may just want to initiate a phone call to start a call to a specific phone number for the user. Let's look at that first example. And I'll say, don't use IMEI as a unique identifier on the device. And the reality is because not all devices have a telephony stack in the first place. Most tablets out there, for example. If you need some sort of identifier, you can always build one yourself. You can use like Java util UUID and persist it locally in your app data storage and then communicate that with your server when you're interacting with it. Another alternative is the instance ID that's provided through Google Play Services. And that's also useful. It provides a unique identifier that then you would use if you're integrating with Google Cloud Messaging, for example. Second of all, if you're looking for that unique identifier for managing app licenses, there's also a solution in Play. The Play licensing server is another alternative to look at there. So takeaway is, please don't use IMEI because it's not really as useful as you think it is. For that second example of making a phone call, there's two intents here that are interesting. There's a slight nuance between the two. There's action call and action dial. When you send an action call intent, you're actually taking the phone off the hook, dialing the number, and it starts ringing for the user. Like they'll hear the actual ringing as it initiates the phone call. Action dial, on the other hand, simply launches the dialer activity, the UI, and inserts the number. It types the number in, the phone number you want to call, but it doesn't actually initiate it. It waits for the user to click a button to confirm that they actually want to initiate that phone call. And so the difference between those two is the action call requires the call phone permission. And so if you use action dial, you'll get that same functionality. You're helping the user shortcut into making that phone call that they want, that you know they want to make, but without requesting that permission. And when you think about it, that flow is a little awkward. You're asking them for the phone permission, allow, and then you're immediately launching the phone call. You think about using action dial instead. You launch them into that familiar flow, they click the call button, and they're on their way. And here's just a quick example, building up that tell URI and sending action dial. Let's talk about the camera or mic permissions. When you request these, you're requesting full access to the camera and microphone from now on. Maybe, when in reality, maybe you're just interested in taking a photo or a small video for the user just for this moment in time. Maybe, for example, a picture of a check that the user just wrote that they want to cache. So it's really just some of the common one-off use cases. And you may not need that permission all the time going into the future. And there's some nice intents that can help you out here. On Media Store, there's action image capture and video capture. And one of the biggest benefits here is that you're launching the user into a consistent experience. If you were to request the camera permission and build your own UI, and then you need to represent advanced features like turning the flash on and off, or turning on other camera features and functionality, you're probably going to do that in a different way, using different UI than the user's used to. The camera app that's built into their phone may represent it one way, and then you're giving them a slightly different UI that'll take them a longer time to get used to find out where all the additional features and functionality that they're used to having access to. So by using these intents, you're actually launching into the built-in camera app on the system, the one that the user has chosen, where they've probably already taken dozens of photos in the past. They're already familiar with how to choose the advanced functionality, and so it's making the user experience faster for them. They're able to jump right in, they understand the flow and how to use it, and then they get the content back that they need. The one thing that I will mention here is you may think, well, I'll try requesting the camera permission, and if the user denies me, then I'll fall back to using some of these intents. And that's something we don't want to encourage. If you need the full camera experience, ask for the camera permission and make sure that the user either allows or denies it, and don't try falling back. Go for the one that you want. If you really need the full camera permission, ask for it. Or if you don't need the full camera permission, just use one of these intents. And the reality is, if you ask for the camera permission and the user denies you, and then if you try using one of these intents, the system will throw a security exception at you. So this is purposely, we want to have you focus on either one path or the other. Contacts permission. Let's talk about those. Read or write contacts. And again, this is accessing all the user's contacts, all the people that they've added over the years. When in reality, you may only be interested in just reading one contact. You want to share something with one person. Or maybe you just want to add a little bit of additional detail to an existing contact, maybe a new email address. So we'll dig into two quick examples related to those. First, there's ActionPic. You can launch that ActionPic intent and ask the user, pick me a contact and return access back. And this, under the hood, is using those same URI permission grants that we talked about a few moments ago. When you launch towards the system asking the user to pick, whatever item that they pick, that contact, that URI is returned to you with temporary permission, that you can read just that contact. You won't be able to see any of the other contacts, but just the one the user selected. So here's that quick example. And there's more details if you go to the link there for the context provider to see how that works under the hood. On the flip side, creating or editing a contact, there's an intent for that. Here, you provide just information that you know. You know their phone number, their name, their email address, and you give the user the choice. Maybe they're only interested, maybe they want to create a brand new contact for this person, or maybe there's this contact already exists and you're just augmenting and adding a little bit of extra details that weren't in there before. This, you're launching towards the contacts up on the platform, and the user is the one left in control. They can make the choice of what to do, create a new one or edit an existing. And similarly here, you're giving them a familiar contact editing experience, something that they've already interacted with on the phone, a URI that they're familiar with. Calendar permission. Again, it's accessing all of the user's contact, all of the user's calendar events. When in reality, you may just want to add like one upcoming event. Say, for example, this talk that we're in right now. Here's an example of how to do that. There's an action insert command or intent for that. And we can fill in some of the details, say like when it starts and ends, the details around it, and then just start that activity. We don't require the right calendar event. We launch into a UI, fill out the fields, ready for the user to say, yes, I want to save and persist that. So we're adding that additional functionality without requiring that permission. So in summary, we talked about how permissions in Marshmallow are much more powerful now. But at the same time, the user has the power to deny us access as developers. They can say no. So what I would say is carefully consider when you're asking this for those permissions, and consider using some of these strategies that we just talked about to build your apps without having to ask for those permissions in the first place, in a way that you can still accomplish the goals, build the app that you want to build with the functionality that you need, but without asking for those broad permissions. And finally, we talked about those intent patterns. So the intents where the user is given common familiar UI, so they have a consistent experience and they're able to accomplish whatever they're trying to do faster. So hopefully you have a better picture of Marshmallow and how the permissions have evolved. And so Svet and I will be available. We're running out of time. We'll be available at office hours later this evening if you have questions for either of us. But without that, thanks for your time.